Hey everyone, if you are building an AI application, you might have heard two buzzwords everywhere, which are RAG and another one is fine tuning. In this video, we will learn what RAG and fine tuning are, how they differ, and which one should you consider using for your use case. But why we need it on the first place? So we have LLMs, which are large language models. They are powerful, but they have two big limitations. So first limitation is they don't know private or latest data. So for example, we say ChatGPT. So ChatGPT won't know that what is the current weather in Ahmedabad or let's say Delhi because it is trained on the data of past. First limitation is that. So second limitation is they don't follow domain specific rules. So let's say I'm running a business and I want to integrate chat support bot. So in that case, what I want LLM to do is they behave soundly, they answer politely. So LLM itself doesn't guarantee that can behave rudely also. So these are the limitations of LLMs. RAG and fine tuning solves these problems in very different ways. Now let's understand RAG first. So RAG stands for Retrieval Augmented Generation. In Retrieval Augmented Generation, we don't change the model. Instead, we provide the context. Here is how RAG works. User asks a question to LLM, then system searches a knowledge base, database or PDF. Let's say I have a database here and it consists the answer of the user's FAQs. So what happens is the system calls this database. So here LLM will make a call on the database. Of course, there will be a function call and the function will return the response to the LLM, which will be the most relevant answer, and then LLM will use the retrieved information to prepare the answer and it will send the answer to the end user. So this is how RAG works. LLM doesn't need to remember your data. What it does it just looks it up whenever needed. On the other end, fine tuning is completely different. Instead of feeding data on the runtime, we modify the model itself. So let's say we have the LLM model here. We train the model on high quality of data and we train it on the custom examples, domain specific rules, preferred response styles. So what we does is we take a base model like GPT 4.1 and then we can train it further on the either we provide it high quality of data to be trained on. After fine tuning the model behaves completely different without providing even extra context. We can think of it like teaching LLM new habits instead of providing it notes to read. Now let's break down the differences. So we have RAG here and we have fine tuning. RAG uses external data on the runtime. So that means we need to provide context on the runtime to fetch the response. Also we can update data instantly. So data can be updated instantly by just updating the context or database itself. So it will fetch the latest data without even training a model or it will be faster. RAG is great for factual accuracy because it won't hallucinate because it will answer upon just our provided context. Also, RAG is easier to maintain because we don't need to train it. We just need to provide it context or we can say the source of truth, which can be anything from databases, documents or PDFs. So it is easier to maintain. On the other end, fine tuning changes model behavior. So it will take time to update the data, but it will completely change the model's behavior and data is backed into the model. That means we don't need to provide any extra context. So data is in the model. It will be stored in the model. We don't need to provide the context. Fine tuning is harder to update. So let's say I want to change the data. So what I have to do is I have to train the model again. So it will be harder to update, because every time we need to update the model, we need to fine tune a model again. That means it remembers the data. So we have to train the model again in order to change the model's behavior. It's better for style, tone, and structure of data. Whenever we need to change the response style or output structure, then we can consider fine tuning a model. A simple rule of thumb we can consider following is: when LLM needs to know facts, we can use RAG, and when LLM needs to behave differently, we can consider fine tuning a model. Now let's see use cases of the both. So RAG is useful when we are working with private or proprietary data. Also, when data change frequently, let's say we have some data which will be changing frequently, we can consider RAG in that case. We can also consider using RAG when accuracy matters more than creativity. So what happens is, when we provide RAG, when we provide context and when we provide the data source, it will surely answer the question upon the provided data. It won't hallucinate, which can be happen in case of fine tuning a model. So for example, we can use it for customer support bots, like I have mentioned. Another example is internal company knowledge assistants. So in that case, company policies can be updated frequently. So in that case, we can consider using RAG. Another example for using RAG is legal or medical document search. Now let's see the use cases of fine tuning. So fine tuning we can consider implementing when we need consistent tone or personality. So once we have trained a model, it will consistently have the same tone and same personality. Also, when we need structured outputs like JSON, we can consider using the fine tuning. And when we need domain specific reasoning patterns, in that case also we can consider fine tuning a model. So examples of fine tunings are brand specific chatbots, code generation assistants, classification or extraction tasks, etc. are the examples where we can consider fine tuning a model. In practice, most of the systems often use both. Fine tuning shapes how the response should be structured, and RAG provides the information it to use. Together they create AI systems that can be accurate and reliable. So remember, RAG provides dynamic knowledge and fine tuning make behavioral changes in the LLM. Choosing the right tool or combining them will make your AI systems far more powerful.